Okay, so this video 12.3, we're going to talk about the percentage yield. You can refer to a textbook page 24 to 25. So what is percentage yield? Before we talk about that, okay, you have to understand several terms first, okay? First, you have to know what is theoretical yield. Next, we're going to talk about the actual yield. So theoretical yield actually is the amount of product we expected from the reaction. Normally, this one is based on calculation. Before we do the experiment, we will calculate how much product we will expect from it. So that one was called theoretical yield. But the actual yield is something that really we obtain, okay, through the experiments. So actually, actual yield is based on the experimental result. If we put it like that way, that will be easier for you to understand. For example, you expect you will finish 5 homework in 2 hours, then the 5 homework, that will be your theoretical yield. But you know that in the process, maybe you watch YouTube, you played video games and things like that. Then the actual homework that you can finish within 2 hours, okay, 2 hours, where you expect to finish 5 homework, that one will be the theoretical yield. But indeed, okay, you may have like some YouTube, okay, and then you play some game, you go basketball, things like that. Then at the end, okay, you just finish 2 homework. So that one will be the actual yield. So in most cases, you will find that the actual yield will be smaller than the theoretical yield. Okay, so we'll find that, okay, normally most cases, okay, there will be less than the theoretical yield. The actual yield will less than theoretical yield. There are certain reasons for that, okay. You may need to memorize some of them, okay. So for example, okay, the reaction doesn't go complete, okay. So maybe the reaction time that you allowed, okay, maybe not sufficient for the reactions to go complete, okay. Only part of the reactants have reacted, or maybe due to the impurity present in it. What means by that? Okay, if I have some sample right there, okay, and then, okay, we expect inside we got HCl, but indeed actually they got some impurity, which is water. So for the HCl, then they can react, okay, to give the product. However, water, they have no reaction at all. So therefore, the product that you got, okay, will be less than what you expected, okay, because you expect all of them are HCl, but indeed, actually, only part of them are HCl, okay. So therefore, some impurities, if it is present in the reactants, maybe the product you obtain will be less than expected. And also some cases, okay, we find that there may have side reaction occur. For example, if you got like carbon and then you try to burn it in the oxygen in the air, you expect to got carbon dioxide. However, actually in the process, you may got some carbon monoxide. Some of the carbon have been used to make carbon monoxide. So the carbon dioxide produced, okay, the actual yield that carbon dioxide produced will be less than expected. Okay, so that will be due to the side reaction occurs. Lastly, okay, maybe some of the product, okay, is lost during the experimental process, okay. So for example, you form some precipitate, you form some PPT. When you do transfer from one beaker to the others, maybe some of the product, the PPT, may left in the original beaker, for example, doing like that, okay. So you try to transfer into another beaker, okay, but some of them they may left right there. Okay, so therefore the product loss, okay, may also be one of the reasons that the actual yield smaller than the theoretical yield. So you will find that, okay, we'll use one calculations to show the efficiency of the chemical reaction. That one is called percentage yield. So percentage yield is pretty easy. You just use the actual yield normally given by question, because you're not doing the experiments, right? So therefore, normally the questions will give you the actual yield. And theoretical yield, that will be based on calculation. Okay, so normally the actual yield is smaller than theoretical yield. So by doing this, you'll find that the percentage yield normally will be less than 100%. Okay, so remember, okay, you have to know how to calculate the percentage yield, and you have to know some of the reason, okay, why there will be having a smaller actual yield than theoretical yield. Okay. So we'll just have one example. So example 12.14, okay. So from here you will find that okay we've got copper dioxide, and also you got hydrogen. So two masses are given, and both of them are the reactant side. You expected this will be related to limited reagent. Okay, it will be related to limited reagent. Okay, so first of all, okay, we will find out we got the equation, and then you're going to find the data. The data that we have, okay, we have CuO, and then we have 0.6 gram hydrogen. Okay, so what we're going to do, we're going to find out the copper. Okay, so number 3, okay, you're going to find out the copper dioxide. You will have 15.9 gram over 63.5 plus 16. So this one is around 0.2 mole, while the number of mole of H2 will equals to 0.6 over 1 times 2. So this one is 0.3 mole. Okay, because we got two reactants, okay, we have to find out which one is a limited reagent. Okay, so to react with 0.2 mole CuO, we need 0.2 divided by 1 times 1. Why would be like that? Because you got 1 here. Okay, so divide by 1 times 1, so you'll find that it will be 0. We need 0.2 mole H2. Now we have 0.3 mole, right? So now we have 0.3 mole H2. So the one that we have, okay, is more than we need. Okay, so therefore H2 is in excess. If H2 is in excess, that means that CuO is limited. So we use CuO to find Cu. Okay, so step 4, okay, number of mole of Cu will then be based on CuO number of mole, okay, and then divided by 1 times 1. So this one will be 0.2 mole. Okay, and then the mass, we add a word, theoretical mass or theoretical yield of copper, okay, of copper would then be equals to 0.2 times 63.5. So the answer for this one is 12.7 gram. Okay, so that will be part A answer. Okay, and then part B, okay, given that, okay, the percentage yield of the copper is 82%. That means, okay, they will expect only 82% of the expected product. So what we have to do to calculate the actual yield will then equals to the theoretical yield times the percentage yield. Okay, so right here we'll have like 12.7 times 0.82. So the answer for this one will then be 10.4 gram. Okay, so during the exam, do you need to write this statement? Okay, of course not. Okay, this one just for your own reference. Okay, so I'll just put the theoretical yield from the denominator to the other side, to the right hand side. Okay, so we'll just have theoretical yield times percentage yield, then you got the actual yield. Okay, so next, one more examples. Okay, so we have aluminium react with chlorine. Okay, and then according to the equations, okay, short right there. So you got like 2Al plus 3Cl2 and become 2AlCl3. Okay, so we have like 8.1 gram aluminium, and then we have like 38.2 gram. That is the actual mass, actual yield, okay, of the aluminum chloride. We want to find out the percentage yield. So you see that the actual yield, they will be given by the question because you don't know the experiments, right? So what we're going to do, we're going to find out the theoretical yield first. Okay, so first of all, you find the number of mole of Al, which will be 8.1 over 27. So this one is 0.3 mole. Because this one it doesn't involve limited reagent, so very quickly we can find out the aluminium chloride by having it divided by 2 times 2. Okay, why have we times 2 times 2? Because divided by 2 and then times 2. Okay, and then you have the number of mole, 0.3 mole. Next, okay, you're going to find out the theoretical mass. Okay, theoretical mass of aluminium chloride. So it will be 0.3 times 27 plus 35.5 times 3. Okay, so the answer for this part, okay, will be 40.05 gram. Okay, so what is the percentage yield then? Okay, the percentage yield will then equals to the actual yield over theoretical yield, okay, times 100%. So the answer for this part will then be 95.4%. Okay. So you got more practice, okay. You have like on page 25, you got self-test. Okay, this one is pretty simple. So you need to calculate the theoretical yield. Okay, you are given like 430 gram of H2, and you just need to calculate this one. Okay, and afterward, okay, they give you a percentage yield, okay, and then you use it to find out the actual yield. It's pretty simple. Okay, I'm not going to talk about this one. Wait, for the class practice, okay, you got 3 questions there. So I would like you to finish it on your own as well, but just want to draw your attention. Okay, one of the questions will involve limited reagent. Okay, you have to pay attention to this one, question number 2, because you got the mass of magnesium and you got the mass of titanium dioxide. You got the mass of these two. So you need to find out which one is the limited reagent. Okay, and the last things I want you to pay attention to is question 3C. Okay, so after you do the question, you will find that, okay, the mass of calcium hydroxide obtained from the experiment was less than theoretical yield. Okay, of course, the actual yield all the time will be less than theoretical. But they need you to work out why they have a smaller actual yield. So you can referring to some of the reasons that we have mentioned before. Possible reason maybe the calcium was impure. Okay, the impurity inside the calcium may not have reaction. Okay, so other than that, okay, some of the calcium hydroxide form may be lost, okay, during the filtration. So in this case, you'll find that, okay, not likely side reaction will occur, okay, because if you take a look of the reactions, okay, and after you learn more chemistry, you'll find that in the process, okay, the calcium react with water, it's not likely to have other kind of side reaction. So those reactions mentioned in the previous slides, okay, not necessarily every one of them will be applicable, okay. So more common one, you'll find that they will have impure substance, okay, so impurity have no reaction. That one is more likely to be correct most of the time, okay. And also if you form some solid sample, so maybe the solid sample they may lose during filtration. You have to be more specific. They may be lost. Okay, why they were lost? Okay, maybe due to the filtration process. Some of them they leave on the filter paper. So this part, okay, I want to draw your attention, which is part 3C and also question 2. Okay, so in conclusion, percentage yield, okay, equals to the actual yield over theoretical yield times 100%. Okay, actual yield normally will be given by the question. Theoretical yield will be based on calculation. All the product of the mass, okay, calculate, okay, normally they are the theoretical yield. And in most cases, you'll find that the percentage yield is less than 100%. If you got more than 100%, normally you got a wrong calculations, okay. So mentioned before, actual yield will be smaller than theoretical yield, and also this reason why actual yield is smaller normally is due to incomplete reaction, side reaction. Not necessarily everyone will have a side reaction, okay, but pay attention to that, okay. And sample may contain impurity, and we assume the impurity will have no reaction with the reactants, okay. So this one, just give you an example. For example, you have HCl react with the maybe lead, okay. So when HCl react with lead, okay, HCl will have lead reactions, okay, but inside the lead, okay, maybe they contain some copper, okay. okay, they may contain some copper. So lead will have reaction, but copper, they don't have reactions, okay. So you'll find that, okay, the product yield, okay, they form will be less than expected, okay. So that's all for this video. Bye bye.